Welcome viewers. Today we are going to see a topic, electroactive polymers. It is a class of smart materials. So I am Dr. S. Rekha, Associate Professor, RFK Engineering College, Chennai. Let us get into the topic. What are electroactive polymers? These exhibit a change in size, volume, or shape when stimulated by an electric charge. Example, piezoelectric, thermoelastic polymer, shape memory alloy, and polymer or magnetostrictive materials. It has a very simple structure comprising of film elastomers sandwiched by the two compliant electrodes. See here, you can see the figure. So here we have the material, and above this material, above and below this material, we have the electrodes. Okay, so the material is sandwiched between two electrodes. And this when changes in shape, you can see the figure, changes in shape, you can see there is a charge developed on the surfaces. So plus is visible, minus is at the bottom. So this brings out the difference in potential. So this can be used as a stimuli for a smart material. Okay. So important properties, it is flexible and elastic material. Okay. And can operate an electric control generator and actuators. These are, you finds application in electric generator and actuators. Okay. So what is electroactive material? Change in size, volume or size to the stimulus of electrical charge. When an electric charge is applied, so it changes in shape or size. What it can do? It can act as an actuator. Okay, it can act as a sensor. It can act as an energy harvester. Okay, it can act as a sensor. Take a film and stretch it, and it will tell how much stress is applied to the film. So it acts like a sensor. It senses the stimuli and gives you the report. Act as an actuator. When an electric field is applied to the film, it will change the shape or size, its volume, okay, and move various fluidic products such as pump or valve application, then electric field. So using an electric field, you can open or close the valve with this electroactive material. Another interesting work it can do is as energy harvester. As a film is stretched, then allowed to relax, it will generate a voltage which is stored in a battery or a capacitor. So it can be used as an energy harvester. Classification of EAP. So it can be classified based on the stimuli or based on the principle. We find various classification. So electric EAP, electroactive polymer, ionic electroactive polymer, non-ionic electroactive polymer, conductive polymer, right? Example of electroactive polymer, electric EAP, we have PVDF. Last session, we have discussed about PVDF, right? Ionic EAP, EAP polymer gels find varieties of application. Non-ionic EAP, it is PVA-based polymers, behaves non-ionic EAP. Conductive polymers, it is polypyrrole and bunene. Polyaniline is an example of this conducting polymers. What are the characteristics of an electroactive polymer? So large active deformation potentials. If a small change in deformation, there is a development of huge amount of potential that is which can be sensed. The change can be observed. High response speed. Yes, as the stimuli is applied, immediately it gives you the response. So it finds application in sensor. Low density and improved resilience finds application in various industries. Extremely lightweight and inexpensive. Inexpensiveness makes it apply in every area, right? Smart materials, one inbuilt quality should be inexpensive. Okay. Then fracture tolerant and compliant. It possesses a fracture tolerant and compliant. It comes for a long time period. What are the advantages of this electroactive polymers? Efficient energy output. It gives you efficient energy outputs. It possesses high strain. It can withstand high mechanical compliances. It's shock absorber or resistant to shock. It possesses low mass density with no acoustic noise. So this makes it for easy application in the industries. Ease of processing of high scalability. That's very important for a polymer. Low cost. I told you cost is important factor for any smart material, right? So it has low cost. Types of EAP, already we have seen the classification. In that we'll discuss two types, basically mainly two types. One is dielectric, another one is ionic. Okay, dielectric materials in which actuator is caused by a electrostatic force between two electrodes which squeezes the polymer. So the two electrode which is on the surface squeezes the polymer in between. They are capable of very high strain. It changes its capacitance when an electric field is applied. So this material, polymeric material, changes its capacitance when an electric field is applied. See in the figure on the right side, we can see the real application of it. When a voltage is applied, the two hands, okay, moves away, leaving the ball down. Okay. Now, when an electric power is not there in figure B, it holds the material. When a power is applied, it drops the material. So in this way, it is utilized the immediate response. Okay. So dielectric response. Ionic variety, ionomeric polymer metal composite is an EAP that bends in response to the electrical activation as a result of mobility of the cation in the polymer network or negative ion in the interconnected cluster. See, in the material we have anions and cations. When an electric field is applied, then all the ions join together to bend the material. Okay, in response to the current, they bend the material. Electrostatic force and mobility cation are responsible for the bending. Mobile cation are responsible for the bending. So here are the examples. So first one already we have seen figure A. B, we have seen another application. When where voltage is off, the ball size you see, it is small. When voltage is on, when current is on, so it enlarges, changes in size, right? Okay, so and it is the circular electrode which is used here. Here it is the linear electrode which is used in the figure C. See, when before voltage is applied, after the voltage is up. So it finds varied applications. Directly we move to the applications. Okay, so here this EAP finds a very beautiful application for the robotic face. What is this robotic face? Why we are bothered much about it? See, our face muscles produce a lot of expressions. When I smile, the chin go up, right? When I am down, when I am sad, chin comes down. So there is a movement in the muscle which tells about our mood. But whenever a plastic is made, such movement is not possible, right? So this EAP finds application in the robotic face. So we can bring expression. You can see the figure B where a robot is smiling. We are able to bring the small changes in movement. So it is used as a facial muscle. Is used as a facial muscle. And you can see in the figure C, you have the hand movement. Okay, muscle has to be in with respect to the hand movement. It should expand and it should contract, right? So here also EAP finds a large role. EAP actuators find a large role. Then we can see figure D where the robotic whole body is made up of this polymeric material EAP so that it can imitate the human being, right? So it acts as a muscle where it stores large amount of energy. Muscle stores energy, right? So here also we saw that out of three properties, one thing is it can store energy. So because of that also it is used as a muscle. Thank you, students. Let us meet in the next video lecture where I will be dealing with funny, which is a important EAP materials. Thank you.